Thought I'd show you number 22 as I go through it. Okay, so this series, again, I wanted to write the word the series or some word, so I didn't start my writing with a mathematical symbol, sigma. It's just good form. The series, okay, now I'm going to say that this is equal to the limit as n goes to infinity of the nth partial sum, a sequence of nth partial sums. Okay, now I do that so that the following stuff can be written. Continuing with my string of equalities, I'm still going to have that limit as n goes to infinity. Don't omit your limit. That you got to write that. If you mean to have it there, you got to have it there. Very common mistake for students to not write it. I don't really understand why, but precious calories, I suppose. Okay, so we can then write out this nth partial sum right here. This would be tangent of inverse 1 minus tangent inverse of 2. Okay, so that's the first term of the sum. Now we're going to add to that tangent inverse of 2 minus tangent inverse of 3. Now, the usual thing is happening here. For each rounded parentheses term that I put in, the second part of that rounded parentheses term and the first part of the next rounded parentheses term will cancel each other, and I will simply be left with the last term will be minus tangent inverse of capital N plus 1, and everybody in here vanishes. So I'm left with the limit as n goes to infinity of tangent inverse of 1 minus tangent inverse of n plus 1. So now I've got to evaluate this limit. So thinking back, tangent inverse of 1, let me set some room aside down here. So tangent of some angle, express that as sine of an angle over cosine of the same angle. Okay. So the question of tangent inverse is for what angle theta is tangent equal to 1, and that happens when sine and cosine are the same thing. So that tangent inverse of 1 is the angle at which sine and cosine are the same thing. Oh yeah, that square root of 2 over 2 thing at 45 degrees, or pi over 4. All right, now tangent inverse of n plus 1, and the limit as n goes to infinity. So at what angle does tangent become really, really big? Well, sine never gets particularly big, so how do I make this ratio big? It's when cosine gets close to 0. So when cosine's close to 0, that would happen, I think, thinking about the unit circle, the theta right there. So this point right there has coordinates cosine theta, sine theta, and the x coordinate is cosine theta, the first coordinate. That would be 0 at pi over 2. Okay, and sine at pi over 2 is 1, so at pi over 2, so as theta goes to pi over 2, at least from the right, this ratio will go to 1 over 0, be positive. So I'm pretty sure tangent inverse of n plus 1 is pi over 2, and I need to subtract that. Okay, so that leaves me with what? Pi over 4 minus pi over 2, that's pi over 4 minus 2 pi over 4, so negative pi over 4.